Hi guys, and welcome to Activity 3 in Physical Sciences for Year 9. In this activity we're going to follow on with what we talked about from Activity 2, where we're going to be looking at the second of our heat transfer processes, and that's the process of convection. Now, as we learned in the previous activity, we've got three states of matter. We've got solid, liquid, and we've got gas. We learned that conduction only occurs in solid matter. Now, convection can occur in both liquid and in a gas, but it can't occur in a solid. So what we're going to do in this activity is run through the various processes of convection, and then I'm going to apply it to some real-world situations. Also, there will be a practical video for you to watch, which will link in with what we've got on this slide here. Now, basically what happens with respect to convection, convection works on the ability for heat energy to move from one place to the next due to the concept of density. Now, when you heat something up, what happens is the space between the particles actually gets further apart. Now, if you increase the space between those particles, what happens is that material then becomes less dense because there's less particles per certain amount of space. So if you can imagine with a solid, there's lots and lots of particles in a very short space, but if you open the gaps up, what happens is these particles then take up more space, okay? So you've got less particles in a certain amount of space, so as a result they become less dense. Now what we know is that something which is less dense rises, something which is more dense sinks. So if you heat an object up, what happens is particles move apart, they become less dense, and as a result they rise. Now this can work really nicely when we're dealing with a liquid or a gas environment because the particles have the ability to move out of the way. So let's look at the scenario that we've got down here, and we've got a beaker and it's been heated by a Bunsen burner, and we've got water in, or a liquid, inside the beaker. So what happens is, at the point where the Bunsen burner is actually heating, the water there, the particles are getting further apart. They're getting less dense. As a result, as it's shown by the black arrows and the red box, that liquid becomes less dense. It's hot liquid, so it rises to the surface. When it gets to the surface, it gives off its heat. Now, if it gives off its heat, what then happens is the particles come closer together. If they become closer together, they become more dense. Becoming more dense makes you heavier, and as a result, you sink. Now, what's happening is all the time, either side of those, if you look at those red arrows moving around in that circle, all the time you've got less dense particles pushing up behind you. So what happens is it spreads out over the surface and then drops down. So basically convection currents work on the principle that anything which is heated as a liquid or a gas becomes less dense, and so it rises. As soon as it loses that heat, it becomes more dense, so it sinks. Okay, so let's have a look at that in a real-world environment. Well, let's look at something along the lines of sea breezes. Now, during a hot day, what will happen is the land will heat up. The land is very good at absorbing heat. Now, what then happens is, as the land heats up, the air above it becomes really hot. As it becomes really hot, it becomes less dense. Remember, it's a gas, so the particles can move. So the particles get more energy, they move apart more, become more dense, and so they rise. As they rise, you produce a potential vacuum underneath the risen air. And what happens is air, colder air, more dense air comes in from the sea. Now remember, the sea is very poor at trapping heat energy. All you have to do is jump into a swimming pool and go to the bottom. Even if the sun has been on it, top surface is nice and warm, but it's really cold at the bottom. So what happens is cold air will actually move in under the risen air. It gets heated by the land, it rises up. And what happens is we get this cycle of events. Now that causes our weather, and is a direct result for when you look at the weather patterns, you see this area of high pressure and areas of low pressure, which are generated, and they will denote different types of weather. We get exactly the same if we look on a geological setup. For example, we will study later on when we look at our Earth Science unit in Year 9 that the whole of the Earth's crust is made up of tectonic plates. These tectonic plates are sitting on jelly magma. Now, this is heated by the core, which is around about 5,000 degrees Celsius. So any liquid which is present down at the core will actually rise up to the surface. Now, as it rises up to a surface, remember we're talking millions of tons of liquid all moving up. What happens is it pushes on the surface, on the crust, can't get out, and where the crusts are meet, where you get two crusts meet, what happens is it pulls the crusts apart. And again, you get this cycle of events. Now, as that hot magma moves up, it gives off its heat to the land, so it becomes cooler, the particles get more dense, and then they sink back to the core. This may take hundreds of thousands of years to occur, but we've still got the same process of convection currents. Okay, this convection going from low density rising, high density falling. Okay, another example is looking at a heater. Now, in this case, what we've got is a heater heats the air around it. That causes the air to rise. Now, what happens inside a room? You put your heater in the room. It heats the air rises, and is replaced. As it rises, it's replaced by colder air underneath. That then is heated. It rises. Colder air comes in. If you seal your room so that you've got no drafts or what have you, eventually the heat inside the room will become the same, and obviously the thermostat will then click off. So again, we've got this idea of convection occurring. If your room is not particularly well insulated, then you'll have drafts coming in under the door, so you'll continuously have cold air. During this winter, see what happens if you take, you're heating a room, and you go and stand close to your door from outside, which may have a draft on it, and just have bare feet, and you'll feel the cold air actually moving underneath the door. Now, it's been sucked in by the hot air rising to the surface. Okay, so I hope that gives you an overview on how convection currents work in the lab, and also how they work in 3 different scenarios, looking at weather, the geological convection currents that we've got on the planet, and also convection currents in the air. Also, what I'd like you to do is, so if you understand that, have a go at the exercises in Activity 3B, and then we've also put together a video watching those convection currents working in action in the laboratory, and I've done a voiceover on that to try and consolidate what you've learned in this video. Okay, well, thank you for watching, and join me again, and we'll look at the third process, which is going to be the process of radiation. See you then.